So in this problem, we are given a demand function and a supply function, both in terms of x, where x is the number of units of an item, and we want to find the equilibrium point, and then the consumer surplus at the equilibrium point and the producer surplus at that point. So first we're going to find the equilibrium point, and that's where demand and supply intersect. So we're going to set those equal and solve. So we're going to set equal 25 over the square root of x and the square root of x. So to solve that, we have a fraction over here, so I would multiply both sides by this radical x. Multiplying both sides by square root of x, on the right we'll have square root of x times square root of x, which is just x. Okay, so that one was kind of simple. So that is the x coordinate of our equilibrium point. We're also going to need, that's the number of items, we're also going to need the number, the price at that equilibrium point. So in the demand and the supply functions, when they're in terms of x, they're giving you the price. So it doesn't matter which one we plug into, we'll get the same price. So the price at the equilibrium point, I'm going to plug into s of x as the square root of 25 or 5. Okay, so our equilibrium point is 25, 5. Okay, then next we need to find the consumer surplus. Okay, so we'll start with the integral formula. So the consumer surplus is the integral from 0 to q of d of x dx minus qp. So what is q? Q is quantity and p is price. And since we're finding consumer surplus at the equilibrium point, we're going to use this quantity and this price. Okay, so that's capital Q and that's capital P for this integral. So our setup is the integral from 0 to 25 of the demand function d of x, and we'll just go ahead and write it as 25 times x to the negative a half dx. That's the end of the integral. Then after we do the integral, we subtract QP, the product, 25 and 5, so 25 times 5. Okay, from here it's computational, so I'm going to pull the 25 out, and we're going to integrate x to the negative a half. So we add 1 to that to get positive a half, so that integral is 1 over positive a half times x to the positive a half, evaluated from 0 to 25, and we'll subtract off 125 in the end. Okay, 1 over a half is 2. 2 times 25 is 50, so this is 50. X to the half, let's go ahead and write it as square root of x, evaluated from 0 to 25. So plugging in 25 gets 50 times the square root of 25, minus 50 times the square root of 0 is 0. And we're almost there. Okay, square root of 5, or square root of 25 is 5, so we have 50 times 5 minus 125. So let's see, 50 times 5 is 250. 250 minus 125 is 125. Is the consumer surplus. Okay, then for part C, to find the producer surplus at that point, producer surplus equals QP minus the integral from 0 to q of s of x dx. QP is 5 times 25, or 125, minus the integral from 0 to the quantity q is still 25, right here. The function s of x was the square root of x dx. And I think based on what I've done up here, you should be able to compute that integral. Well, in this one, there's not much to get stuck on. I was going to say the one thing to be careful about is this minus. I did see some people forgetting to, distribute over any multiple terms in there, but that shouldn't happen in this problem. So let me know if you have any more questions about this problem.